Okay, so now we move to the next section of the lesson. We are going to learn about mutually exclusive and independent events. Okay, so we're going to learn the two types of events. But I think these are again things that you might have heard in your O levels. But anyway, we'll go through them. Okay, so first we'll learn about mutually exclusive events. So when events have no outcomes in common, they are called mutually exclusive. So I think you can see in this example, in this diagram, I think you can see quite clearly there are two events. The first event A, second event is B, and you can see that the two circles are separate. They're separate of each other. There is no intersection. There is no common element between the two circles. Can you see? There are no common outcomes because you know in an intersection, if when two circles or when two events intersect, it means at the intersection you have common outcomes that is common to both the circles, right? But over here you can see when the circles don't overlap or when there is no intersection, then such events are called mutually exclusive. In a Venn diagram, the closed curves do not overlap, and you can use a simple addition rule to work out the combined probability. So if you want to work out the probability of A or B, okay, so A or B, you know, or means you're okay with any of them. Okay, as I told you previously, or operator and operator. Or means we are okay with both of them. Okay, so or is like a union. Okay, you should know. I think we will be talking more about this. Or is union, and we use for intersection. Okay, so we'll go with that in a while. So or means union. So basically A or B means we are okay with either A or with B. So you can see in this case when the circles are not overlapping, the probability of A or B is directly equal to probability of A plus probability of B because there's no common part. You just have to get the circle A probability, circle B probability, and add. Okay, so remember when it comes to a or, we are okay with getting A, we are okay with getting B. Any one of the two is fine. So that's why we have both of these areas okay. But what about A and B? What if I ask you in this case, what is the probability of A and B? So if you check the probability of A and B, or in other words, A intersection B, you can see that do A and B occur together? Do they occur together? No, right? A and B don't occur together. They don't have a common outcome. There is no overlap. So in such a situation, the probability of A and B or A intersection B is 0 in this case. Okay, so these are some important things that you should remember. Okay, so when it comes to mutually exclusive events, probability A or B is equal to PA plus PB. So that's one important rule. Okay, so that's one important rule. And the other one, when for mutually exclusive event, probability A intersection B is equal to 0. There is no intersection. Okay, so this is a thing that you need to note down. All right, so now we'll move on to the next part. The next section we are going to learn. We're going to learn about independent events. Okay, so what are independent events? When one event has no effect on another, okay, they are independent events. Okay, now this is completely different with mutually exclusive. Okay, so this is a different story. Now this is a different thing. So try to put it into your brain in a different section. Okay, so basically independent events are events where the two events A and B, there is the occurrence of event A makes no impact on the on event B. So event B happening not happening does not have any impact on A, and A has no impact on B. Okay, so therefore if A and B are independent, the probability of A happening is the same whether or not B happens. So whether when A is happening, it doesn't make any impact on B. Okay, whether event A happens or not, event B has no problem. So a simple example of such event, we can say event A is tossing a coin, and you can say event B is tossing a dice. So when you toss the coin and whatever the outcome you get head or tail. Getting a head or getting a tail, does it make any impact on what you get with the dice? No, right? From the dice, you can get 1, 2, 3, 4, 5, 6. But from the coin, when you toss the coin, if you get a head, that makes no direct impact. It doesn't make any impact at all with what you get with the dice. So the tossing the coin and tossing the dice are independent events. Is that clear? Okay, so they are saying because the events don't make any impact on each other, So for independent events, probability A and B. So now in the case of independent events, there can be common outcomes. Okay, there can be, we can define it in such ways where there is definitely an overlap. Okay, so independent events will have an overlap. Okay, so independent events will definitely have an overlap there. So basically the intersection A intersection B or A and B. The A and B means where I want both the two events to happen together. Okay, so I'm saying that from the coin I want a head and from the dice I want a one, something like that. You can say like that. Can you understand? So you can say, we can say, okay, A is the event, I'll get a head from the coin. And B is the event, I'll get one from the dice. So I want A and B. Can you see? So this is A and this is B. So probability A and B. A and B means, I told you, and means like an intersection. So this is equal to PA times PB. So all you have to do is multiply the individual probabilities, and this is really important. Okay, so this is really important because independence is something that they'll be testing you in the exam. Definitely, this part will be tested. So they will be asking you to determine whether the two events A and B are independent. So they are independent given on the based on the fact that A intersection B or PA and B, both events occurring together, is equal to PA into PB. Okay, so if this condition is satisfied, then we say that the events are independent. Okay. All right, so we'll move on to exercise 4C and let's practice with the concepts now. So they're saying question number 1, events A and B are mutually exclusive. So guys, the moment you see this, immediately you know the circles have no intersection. The two circles, the two events have no outcomes in common and the intersection probability is 0. So if you want, you can even quickly, draw a Venn diagram to mark all the information. I think that's what they ask in part A, draw a Venn diagram, right? Okay, so basically A and B are mutually exclusive. Probability of A is 0.2, probability of B is 0.5. Draw a Venn diagram to represent these two events. So let's draw the Venn diagram. So basically, if it's mutually exclusive, the two circles don't meet with each other, right? So you name the two circles A and the other circle is B. So probability of A is 0.2. So guys, because there is no intersection and the circle doesn't have any regions directly, you can mark the 0.2 probability inside the circle. Because the circle doesn't have any, it doesn't have any, the regions inside the circles are not divided because the region inside the circle is completely one. And probability of B is 0.5. This universal set. Draw Venn diagram to represent these two events. That's done. And also, by the way, you should know the total probability is always adding up to 1. So therefore, if this is 0.2, if this is 0.5, then immediately you can tell the probability that's outside the two circles because the universal set total probability is 1. So in that case, this probability becomes how much? 0.2 plus 0.5 is 0.7. So from 1, when you subtract 0.7, you get 0.3, right? So outside probability 0.3. That is the probability that we don't get event A and we don't get event B both. The probability of neither of the two events happening is 0.3. Is this clear? I added the 0.2 and 0.5, that's 0.7. And then I subtract it from 1. Okay, so this is my complete Venn diagram. I have marked all the probabilities in the complete Venn diagram. So part A Venn diagram is done. Part B, find the probability of A or B. So guys, you remember in mutually exclusive events, if circles don't meet. So if the circles don't meet, probability of A or B is probability of A. You add with the probability of B. Is that clear? Probability of A, you add with probability of B. So probability of A is 0.2 plus probability of B is 0.5. So when you add this, it's 0.7. Agreed? Is that okay? Part C, probability neither A nor B. Neither A, neither of them. So neither of them. So neither of them is I don't want A, I don't want B. So what's the part outside both A and B? That's the part outside the circle, right? So that's the 0.3 or 1 minus the 0.7. That's 0.3, right? So I think this is pretty clear, right? Okay, so we'll move on to some more questions. Okay, so next we'll move on to question number 6. They say the Venn diagram shows the probabilities that a group of students like pasta, that's event A, or pizza, that's event B. Write down the value of X. Okay. So how do we write the value of X? I think you can see there are in this particular Venn diagram, you have 4 regions, right? 0.4, X, 0.3, 0.05. So the rule is total probability must be equal to 1. So 0.4 plus X plus 0.3 plus 0.05 must be equal to 1. Okay, so for X plus 0.75, right? X plus 0.75 is equal to 1. So X equals 1 minus 0.75. That's 0.25, isn't it, guys? So that's X equals 0.25. Agreed? Okay, so X equals 0.25. That's the answer for 1 mark. So part B, determine whether the events like pasta and like pizza are independent. Now remember, like pasta is event A. Like pizza is event B. Okay, so if the events are independent, what's the rule? So we just learned if 2 events are independent, probability A and B should be equal to probability A times probability B. If this is true, if this equation is true, then events A and B are independent. If this equation is not true, then they are not independent. It means they have some kind of a dependency. Okay, so can't we get the probability of A and B? Guys, A and B means what? A and B means the probability of A and B both happening together. So the common part, I think you can see the common probability here is X. Can you see? Common probability, A and B probability here is X, right? The intersection. That's where you have the AND. So A and B is X, X is 0.25. And now let's get the probability A times probability B. Guys, what's the probability? I think we'll get the probability A first. Okay, what's probability of A? Probability of A means you get the circle A. So what's the probability of circle A? 0.4 plus X, right? How much is it? 0.4 plus 0.25. That's 0.65, right? Get the probability of B also. So probability of B, you get the B circle completely, this one. So that's X plus 0.3. So X is 0.25 plus 0.3. So that's 0.55. Right, is that okay? Now what we do is we multiply PA into PB. So multiply. Check and see whether probability A into probability B is the same. So 0.65 into 0.55. So multiply. Can you see? What you should do? 0.65 into 0.55. When you multiply, I get the answer as 0.3575. Guys, can you see? I get the answer as 0.3575. Okay. So what does that tell you? So what do we understand from here? So what we can see here is probability A and B answer. Does it match with PA into PB? No, right? Because you can see probability of A and B is 0.25. That doesn't match with 0.3575. I mean, the two answers don't equal to each other. So because they are not equal to each other, what do we conclude? We say therefore, you can say therefore, A and B are not independent. These are not independent. Is this clear? Okay, so this is the answer for the question. All right, so we'll move on to question number 9. The Venn diagram shows the probabilities of members of a social club taking part in charitable activities. A represents taking part in an archery competition. R represents taking part in a raffle. F represents taking part in a fun run. The probability that a member takes part in the archery competition or the raffle is 0.6. Okay, so they have told you the probability of a member taking part in archery, that is the probability that member takes part in archery, so PA or raffle. So A or R is equal to 0.6. Find the value of X and the value of Y. Show that the events R and F are not independent. Okay. So guys, first things first. When we talk about event A and event R, what's the first thing that comes into your mind? Event A and event R. Clearly, we can see that the two events are what? Event A and event R are mutually exclusive because event A and event R has no intersection. They don't meet. So definitely event A and event R are mutually exclusive. So if they're mutually exclusive, A or R is equal to what? Probability of A or R is equal to, guys, do you recall? So the rule of mutually exclusive, probability A or R is equal to probability A plus probability R. Probability A or R is equal to probability A plus probability R. So probability A or R, they have given A or R, the answer is 0.6. Can you guys see? I just use this value here. Probability of A, we can very clearly see it's 0.2 plus probability of R, guys. So R is this circle, right? So R is the circle, it's 0.25 plus X. So 0.6 equal 0.2 plus 0.25 is 0.45 plus X. So X equals 0.6 minus 0.45. So X equals to 0.6 minus 0.45, which is 0.15. So X is equal to 0.15. Okay. So find the value of X, that's done. And then how do we find the value of Y? Obviously by considering the whole thing. So when you consider the whole thing, I mean, the total probability must add up to 1. So 0.2, you cover this part. 0.25, you cover this part, plus X plus Y, that's this part. And outside you have 0.1. This is equal to total probability 1. Can you see? So I have covered every single part in the Venn diagram. 0.2, 0.25, X plus Y plus 0.1. Everything adds up to 1. X value is found. 0.2 plus 0.25. X is 0.15 plus Y plus 0.1 is equal to 1. Can you see? Make Y the subject and you can get your answer. 0.2 plus 0.25 plus 0.15 plus 0.1. Add everything together. Yeah, that's 0.7, right? So Y equals 1 minus 0.7. Y is 0.3. Agreed? Y is 0.3. So I have found the values of X and Y. That's the answer for part A. So moving on to part B, they say show that the events R and F are not independent. So how do you show that they are not independent? So first you get the probability of R and F. So you know the rule. If the events are independent, then probability R and F equal probability R times probability F. This is the rule to be independent. If this is satisfied, then the events are independent. If this condition is satisfied, the events are independent. But now they are asking you to show it's not independent. So you have to show that the answers are not equal. Guys, so probability R and F. What's the probability R and F? I think you can see R and the R circle and F circle intersect. Very clearly they intersect. And the intersection is the X. Right? So X value was found as 0.15. So probability R. Probability of R means the R circle, it's 0.25 plus X, right guys? 0.25 plus X. So get the answer. 0.25 plus X is 0.15. So that's 0.4. Okay, and get the probability of F. So probability of F is X plus Y. Can you see, because the F circle The F circle is X plus Y. So X is, guys, X is 0.15 and Y is 0.3. So 0.45. Can you see probability R is 0.4, probability F is 0.45. Now what do we do? Get probability R multiply with probability of F. Probability R is 0.4 multiply with probability of F 0.45. So multiply and get the answer. 0.4 into 0.45 is 0.18. Can you guys see? Probability of R into R, probability of F is 0.18. So probability R and F, what do you think? Are they equal? Probability R into probability F, are they equal to each other? No, right? Because you can see probability of R and F is 0.15. So this is not equal to 0.18. So therefore, events R and F are not independent. So which means they depend on each other. So that means they have a dependency. R and F are not completely independent. Is this clear? Okay. So I hope this part with mutually exclusive events and independent events are clear with everyone.